Hi everybody, Aaron here. I'm going to talk today about a little bit of the mechanical engineering that went into my newest build, the Shipwreck. This underwater scene was inspired in part by a build that Christian and I did on LEGO Masters called Beneath the Surface. That too was a really intricate underwater scene with a big kraken and a ship and a coral reef and a micro scale city. This one here is a minifigure scale scene but has a lot of the same parts, and it also moves. When I flip this switch right here, the build becomes not just a scene, but a kinetic sculpture with moving parts like swimming fish, a bobbing boat, a swimming diver, even some fighting crabs down on the sea floor. I've achieved motion on this build using LEGO Power Functions, which is a motorized system that can sort of bring some electrical, mechanical life to your LEGO creations. I've used two main Power Functions components to make this scene move. The first of which is a battery box. This is the power source for my build. I also use two of these motors. To demonstrate how this motor works, I'm going to stick a little flag into it, hook it up to my battery box. When I turn on the battery box, the motor starts to spin. However, as you can see, the moving parts on the Shipwreck aren't all just spinning in place. I've actually used some mechanical systems to translate rotational motion into other kinds of motion as well. Let me show you how that's done. The first thing I want to show you are gears. Gears are these little wheels that have teeth on them, and when two gears mesh, when the teeth are sort of shaking hands, I can turn one gear and the other gear will turn as well. Sometimes I also want to change the direction of an axle using gears. Right here I've got some different gears. These are called bevel gears. Bevel gears are shaped a little bit like a trapezoid, so when they mesh, they meet at a 90-degree angle, which is very useful for turning corners, or, as in the case of the fish, going from horizontal to vertical. Pretty cool, huh? The boat moves up and down. How did I achieve that? I did it using something called a cam. A cam is something that's attached to the center of rotation, the axle in this case, that is uneven. So when it moves around and around, it actually pushes up the axle that's holding the boat. Pushes it up and lets it down. You may also notice I'm using this rounded ball joint here on the bottom of the boat axle. The reason that's there is just to make the machine a little bit more efficient. When the cam encounters the ball joint, it's just a little easier for it to move up. So I like to use that to make the cam's motion a bit smoother. So with the boat, I was able to change the original rotational motion into something a little bit more linear. But with the cam, I got something that was a little bit more static, like an up-down, up-down. If I want something that's got a bit more of a fluid motion, I like to turn to a piston. So when I turn this axle, this wheel here moves around and around. And as you can see, through this connector, I'm able to turn that rotational motion into a reciprocating back and forth motion. I used it for the crab fighting. I also used it for the moving diver. Pistons, pretty cool. Thank you very much for watching. I hope my breakdown of the Shipwreck has been interesting to you, and I would love to see how you use some of these different machines in your own LEGO creations as well. Take care, see you next time.